Sige, let's continue our discussion with the colligative properties. Let's just have a little review. When you say colligative properties, these are the properties of our solutions which are dependent on the number of solute. So, ang ato alang tan-awon dinhi kung unsa kadaghan ang ato ang solute in terms sa iyahang concentration. So, wala naga-matter ang identity kung unsang klaseng solute siya, kung unsa ang iyahang characteristics, but dito atong tan-awon sa iyahang concentration. Mo to ang naga-matter when it comes to colligative properties. Now, we have 4 types of colligative properties, and I think we are done with the first one, the vapor pressure lowering. That's the first one. So, when you say vapor pressure lowering, it is governed by the Raoult's law, wherein we use the formula, the new vapor pressure is equal to the X, that's the mole fraction for our solute, and then i-multiply lang siya sa vapor pressure ng ating solvent. So as a rule, sa vapor pressure lowering, kapag you add more solute, especially if your solute is non-volatile, the vapor pressure will be lowered, resulting to dugay na mag-evaporate ang atoang solution. So that mo na siya ang result. So dili na siya basta-basta mag-evaporate or mag-volatilize if you add a non-volatile solute to a volatile na solvent. Okay? And then I guess we have started with the boiling point elevation, though wala pa nako na solve ang next na problem. So do not forget, class, when you say boiling point, this refers to the point wherein the vapor pressure will be equal to the atmospheric pressure. So pag mayroon kag atmospheric pressure, it's the external pressure or the pressure above the liquid or the pressure sa the environment. So kung magpantay na silang duha, that's that time the solution will boil. So when will that be? Kailangan og certain temperature before nimo ma-achieve na mag-equal si vapor pressure kay atmospheric pressure. So ang atmospheric pressure, wala na siya nag-change, wala na siya basta-basta nag-change. Therefore, ang ato ang i-change dinhi ang vapor pressure, and that's through the application of heat, or there is a certain temperature required. So, please remember our formula for the boiling point. It's change in the boiling point. This is the change in the boiling point, equals KB, that's the molar constant or the molar boiling point elevation constant. So most of the time this will be given in the problem because this constant is unique for each substance. So again, I will not be requiring you to memorize the molar constant because we have a lot of chemicals and each of them has their own molar constant. So again, this will be given in the problem. And then small letter m refers to the molality of the solute. So this one is the concentration. Again, this is the concentration. And if ever, class, na molality is not given in the problem, then you may compute it using the formula. You know it very well. We are done with the concentration computation. We have moles of solute divided by kilograms of our solvent. So this one is an example of substances with their boiling point and their corresponding molar boiling point elevation constant. So most of the time our solvent is water, And you know it very well that it boils at 100 degrees Celsius. However, its molar constant is 0.512. Now, kaning uban din, these are other solvents that we can use when we prepare our solution. So later also, we will be using this part for the freezing point. So naapod siya sarili niya na freezing point constant. So I think I have done computing the problem number 1. Let's move on to problem number 2. So for problem number 2, this is for the boiling point elevation constant gihapon. Find the boiling point of a solution of 92.1 grams of iodine in 800.0 grams of chloroform. So that's CH3Cl. Assume that the iodine is non-volatile and that the solution is ideal. Okay? Sa daw ang ginapangayo sa atong problem, let's analyze. Okay. So again, what is asked in the problem is you have to compute for the boiling point of our solution. Now remember, pag sinabing solution, we have two components. The first one is the solute, and then the other one is the solvent. So in this case, if that is not identified in the problem, ang pinaka dali himuon is, do not forget, when you say solute, it has much lesser amount compared to the solvent. So as you can see, you only have 92.1 grams of iodine there, which means this is the solute. And then you have here 800 grams of chloroform. It's much more than the iodine. So this one is the solvent. However, we just need the formula change in your boiling point is equal to Kb times M. So we are looking for the change in the boiling point. And for the Kb, we can go back to our table. Our solvent here is chloroform. So we just need the Kb for chloroform. So let's go back to the table. This one is chloroform here. The Kb is 3.63. That's how you use the table. So again, we have here the Kb 3.63. Do not forget our unit, degrees Celsius per molal. Now, the question is, in the problem, is the molality given? As you can see in the problem, class, sorry, let's move. Okay, this is the problem here. Okay, so the molality is not given, so we need to compute for it first. So molality, remember, is the moles of your solute divided by kilograms of your solvent. Okay, so let's start with the moles of our solute. The solute here is iodine. It's 92.1 grams. It's still in grams, but sa stoichiometry, you have learned how to convert grams to moles. So we need to compute for the moles first. Okay, sige, noted. Okay, so again, let's convert grams of iodine to moles. So moles is equal to the weight of your substance divided by its molecular weight. Okay, so the weight here is 92.1 grams. However, for the molecular weight, let's look at the atomic weight of iodine. If you have your periodic table, please look at the atomic weight of iodine. Sorry. Okay. Let's see. I don't have my periodic table, so I need to look at the net. You have your periodic table. So it's 127. Let's use that. However, take note, class, this is I2, which means we have 2 atoms of iodine here, which means that is 127 times 2. Okay? So 127 times 2 is 254. Okay? So I hope nasundan ha. Again, this is I2. So dili lang 127 inyong gamiton. You have to multiply it sa 2. So this is, sorry, 254 grams per mole. So makancel lang grams. The moles of our solute here is 92.1 divided by 254 is 0.36259,598,425. Okay, so na itong gamiton sa computation. 0.36259,8,425 moles. So next, kilograms of solvent. So this is in grams, therefore you just have to convert this. So 800 grams. How do we convert this? So grams ang sa baba ha, kilograms sa taas para ma-cancel. Manay nyo hang always i-remember. So our conversion factor here sa isa ka kilograms na akay 1,000 grams, which means you just have to divide 800 divided by 1,000. This is 0.8 kilograms. Okay? So kompleto na. This is now 0.8 kilograms. Let's divide. Let's admit first those na late. Okay? So, I hope nasundan pa. So, 0.362598425 divided by 0.8. Our molality here is 0.453248. Sorry, 453. This is 2. Wait, let me delete this. Yan, 453,248,031. This is moles per kilogram or simply small letter M. So, mo ni siya itong gamiton karon sa pag-compute sa change in the boiling point. So 0.453240831 molality or molal. Call it molal. Small letter M is molal. 453248031. So let's multiply. Cancel ang M, ang mabilin kay degrees Celsius because we are talking here about change in boiling point. It's the temperature. So our unit is degrees Celsius. So 3.63 times 0.453248031 is 1.645290354 degrees Celsius. Okay? But, take note class na wala pa tanahuman sa ato ang computation. Nga naman, kasi when you look at the problem, it's not actually asking for the change in the boiling point. It's asking for the boiling point of a solution. So, kailangan dyan na ito pangitaon ang boiling point, not just the change. Kasi ang triangle PB, it means the change in the boiling point only. Dili na siya mao ang boiling point. Therefore, we need the next formula, which I had already given last time. I hope you can still remember. So, the boiling point here, unsa kung gigamit last time, it's the BPF. Ayan. So the final boiling point of our solution is equal to the change in the boiling point plus the original boiling point of our solvent. Okay? So the final boiling point is computed like this. We have the final boiling point is equal to the change in the boiling point plus the original or the initial boiling point. The initial boiling point here refers to the original boiling point of your solvent. So in computing for the final boiling point, you just have to add 1.645290354 degrees Celsius plus, take note, our solvent here is the chloroform. So let's go back sa atuang table and let's see what's the boiling point of chloroform. So for chloroform class, you have there 61.26. That's the original boiling point for our chloroform. 61. Ay, adjust. Ayan. So 61.26 degrees Celsius. So let's add 61.26 plus the change in the boiling point. It's 1.64 or 1.645290354. So the new boiling point here is 62. Let's round up to 2 decimal places. 62.91 degrees Celsius. Okay? So this is now the final answer. Okay? Mauna na siya ang boiling point sa atuang solution if the chloroform is added with iodine. So pag nag-add ka og iodine, 92.1 grams na iodine sa imuhang chloroform, the new boiling point is 62.91. So it's boiling point elevation, meaning pag mag-add ka og solute, then the boiling point will increase. So from the original 61.26 degrees Celsius, the chloroform will now boil at 62.91 degrees Celsius. Questions about this one? I hope nasundan, class. This is recorded, no? Let me check. Yeah, na-record siya for those na hindi makapasok kasi may problems with internet connection. Can I move on now or you want to ask something? You want to clarify something? Wala. Nasundan to. Yeah, oo, noted. Siya makapasok. Okay, so do not forget how our rule for the boiling point. Pag mag-add ka og solute, the boiling point will increase. So when you say boiling point elevation, we are actually talking here about the temperature we need para ang substance nimo mag-boil. Okay? So parehas sa ato ang example, ang ato ang chloroform pag mag-add ka og solute. So example of our solute here is iodine. Mag-elevate ang ato ang boiling point. Mutaas siya. Do not forget our formula. The change in the boiling point is equal to the kBm. If molality is not given in the problem, so you have to compute for it using the formula. Molality is equal to the moles of solute divided by the kilograms of your solvent. Okay? Let me just respond to Mamabe sa section A kasi she is asking question about the computation. Wait lang. Okay. So let's move on. If you don't have questions about the boiling point, let's move on to the third colligative properties. Colligative property, I mean, we call it the freezing point depression. Again, this is freezing point depression. So sa freezing point depression, the presence of your solute, most of the time it's our salt, this will cause lowering of the freezing point. Magbaba ang freezing point ng ating solusyon pag mag-add ka og solute. So this is the opposite of the boiling point. Kasi sa boiling point, pag mag-add ka og solute, mag-increase ang temperature. Pero sa freezing point, pag mag-add ka og solute, mag-decrease ang temperature needed for our substance to freeze. Okay? So pag ang atuang freezing point is depressed or magbaba, this means na the temperature needed must be lowered before ang atong substance mag-freeze. So this will now explain atong sa opening nato last time na I gave you a picture of a dirty ice cream, and then 'di ba ang surrounding sa dirty ice cream na ay ice, and many times makakita ta nga ginabutangan nila og salt. So this will explain it now, the freezing point depression. How do we explain this one? Pag ang ice glass butangan nimo og asin, ang temperature para mag-freeze ang ice is actually mag-lower. However, since init man gud ang surrounding, so pagbutang nimo anang class asin sa ice, ang ice glass paspas na siya noon mag-melt. So baliktad na siya sa ginaisip nato nga pagbutangan nato salt or asin ang ato ang ice, dugay na noon mag-melt ang ice. Baliktad. Pagbutangan nimo siya og salt, paspas na noon siya mag-melt kasi mag-lower man ang iyahang freezing point. And remember that the surrounding sa ice is dili jud siya bugnaw. So mag-melt ang ice glass, and what happens? Nganong butangan, paano na siya naka-help sa dirty ice cream? For example, ang atong dirty ice cream na sa tube, it's surrounded by ice. And then ang ice butangan nato og salt. Ang tendency ana class mag-melt dayon ang ice, and then pag melt sa ice manggod, the surrounding will be what do you call that? The surroundings will be colder. Wait lang. Ayan, i-add lang ako sila. So ang surroundings ana will be lowered, magbaba ang temperature, and then ang ice cream sa sulod, ang dugay mag-melt. Okay? Ano dugay man siya mag-melt? Kasi ang iyahang surroundings is colder compared sa surroundings nga naa sa gawas. Mao na siya ang purpose. So sa uban ng mga countries, kanang mga countries nga naga-snow, actually ginahimo sad na nila. Kapag ka naga-snow class, ang ilahang mga dalan dinha, ginasilhig man na nila ang ice, no, kasi it will become slippery and malisdan na sila. It will be prone to accident kay mahimog slippery pag naay ice. So ilahang ginahimo ang ice glass, ginabutangan pud nila og asin para paspas siya mag-melt and makatabang siya para dili maging slippery ang road. So mao na siya ang application sa ato ang freezing point depression. So again, mas paspas mag-melt ang ato ang ice kapag kabutangan nimo siya og asin, and it will make the surroundings colder. So in the case of the ice cream, dugay na mag-melt ang ice cream sa sulod, kay pag melt sa ice sa gawas, the surroundings will become colder. Okay? Ano siya ang application sa freezing point depression. So, i-try ninyo class. I-try to observe. If namoy ice din ha, i-compare ninyo ang time na mag-freeze sa ice na ice lang and sa ice nga na ice salt. So, pas-pas mag-melt again ang na ice salt. So, for the freezing point, this will be our formula. Change in the freezing point is equal to KFM. So it's the same thing. The triangle there refers to the change, meaning there is a change in your temperature or your freezing point if magdagdag ka og solute. And KF there, KF now is still the constant, but it's for the freezing point. So KF is the molal freezing point, depression constant. And then M is still the molality. So that is the concentration of our solution, but in molality. And then just like our boiling point, we have another formula here. The freezing point, the final freezing point is equal to the change in the freezing point minus, baliktad, sorry. Let me erase this one, baliktad. So this is the initial freezing point or the original freezing point minus the change in the freezing point. So this is the other formula. So please take note. Kasi ang original, the first formula is just for the computation of the change in the temperature. But if you are asked to compute for the final freezing point, then you have to use the next formula. The final freezing point is equal to the initial freezing point or the original freezing point minus the change in the freezing point. So let's have our first example for the computation. So what is the freezing point of the 0.33 molal? Again, small letter M there is molal or molality. So again, what is the freezing point of the 0.33 molal solution of non-volatile, non-electrolyte solute in benzene? Okay? So our solvent here is benzene. Nag-add ng solute and then the molality is already given in the problem. So let's start computing for the freezing point. Take note, it's asking for the freezing point, which means you need two formulas here. So dili lang kataman sa change sa freezing point. You also need to compute for the final freezing point. So the change in the freezing point here is equal to the KF. Let's go back to the table class. The KF is given in the table. Katong gigamit nato sa boiling point. So it's benzene, right? So our solvent there is benzene. And for benzene, our KF is this one, the 5.12. Again, it's the 5.12. So the KF is 5.12. This same unit, degrees Celsius per molal, i-multiply siya sa molal or molality, which is already given in the problem. So it's 0.33 molal. So i-multiply lang, cancel ang M. So 5.12 times 0.33. So it's 1.6896 degrees Celsius. Okay, very good. 1.6896 degrees Celsius. But we are not yet done because it's not asking about the change. It's asking for the freezing point. So we need the next formula. The final freezing point is equal to the original freezing point minus the change in the freezing point. So let's go back again to the table because we need now the freezing point of benzene. Benzene ha kay you should always be looking at the solvent for the freezing point and the boiling point. So benzene freezes at this one, 5.5 degrees Celsius. Again, it's 5.5 degrees Celsius. Asan na? Ayan. So, ayan. 5.5 degrees Celsius, that's the original freezing point minus the change in the freezing point. It's 1.6896 degrees Celsius. So 5.5 minus 1.6896, the final freezing point. Let's round it off to 2 decimal places. It's 3.81 degrees Celsius. Okay? So this is now the final answer. Sorry, line of tutunlan class. Again, it's 3.81 degrees Celsius. So kung nakita ninyo, we have from 5.5, dapat ang benzene mag-freeze kapag you reach or you achieve the 5.5 degrees Celsius. However, pag mag-add ka og non-electrolyte daw na solute, remember wala gipanganlan ang ato ang solute ha, so the identity doesn't matter. Ang ano lang, ang concentration lang niya. So, from 5.5, nahimo na siya og 3.81. So the rule again is, pag mag-add ka og solute, freezing point will be depressed. Okay? So let's, a question for problem number 1. Any clarification? Okay. I hope nasundan. So for problem number 2, please try to answer problem number 2. Last time we have additional points sa exam, no? We have Bailon, Esmalin, Musa, and Agleham. So let's have problem number 2 also. The first one, the first 5 will give me the right answer for problem number 2 will be added in the list also for those na magdagdag ko og points sa results sa exam. So you try answering problem number 2, you follow what I did sa problem number 1. However, if the molality is not given, so you have to compute for it. Sige, I will wait. I will wait for your answers. Let's go back sa kinsa ang nakakuha sa tamang answer. Yeah. Janica, I'll consider the 1.18 times 10 raised to the power of 2. It's the same thing, round off lang siya na naka scientific notation lang siya. So we have Shador. And then we have Mecca. And then we have Agleham. Bitin man ang uban. Okay lang if it's in the scientific mode. Asa man nadapit na kulang. So do not forget ha, do not forget unsa ato ang gibuhat sa problem. First, you have to analyze the problem. If dili mo kasabot, you have to list down the given, and based from the given, you identify what is missing. So kung kulang siya, meaning mao na siya ang ato ang i-compute, mao na siya ato ang pangitaon. So sa problem class, the final freezing point is given. It's 2.32 here. So we use the second formula. 2.32 equals, as a gikan si 5.5, this is the original freezing point of benzene. So please refer sa table, sa given a table, and then you will see there the freezing point of benzene minus the change in the freezing point. Okay? And then transpose sa other side, si 5.5, it will become negative 5.5 plus the 2.32 equals the negative change in the freezing point. So pag i-add nato ni sila, we will get negative 3.18, but we have to get rid of the negative on the other side. So multiply both sides sa negative 1. The change in the freezing point here is 3.18. So ang change sa freezing point will be used to compute for the molality. So that is why here we use the 3.18 sa change in the freezing point. And then as a gikan si 5.12, you cannot see it in the problem, but you can look at the table. This is the freezing point constant for our benzene, the 5.12. Okay, so 5.12 times the molality. Divide nato both sides with the 5.12 to isolate the M. Cancel ang degrees Celsius. So the molality here is 0.62109375. Pero wala pa na siya nahuman kasi molality pa lang man na siya. Ang ginapangayo man is si molar mass. Si molar mass is the same with your molecular weight. So you have to use this formula. Molality is equal to the moles of the solute divided by the kilograms of your solvent. Okay? So the moles of the solute ang ginapangita diri since we have computed for the molality, and for the kilograms of solvent, the amount of the solvent is given in the problem. However, we just need to convert it to kilograms. That is why nahimo na siya 0.055 kilograms. Multiply lang nato, cancel the kilograms, you will get the moles. So naana kay moles class, kailangan na lang nimo ang molecular weight. So you go back to the formula on how to convert moles to grams and grams to moles, vice versa. So this is our formula. Moles is equal to weight divided by the molecular weight. For the moles, it's already computed previously. And then, as a gikan si 4 grams, it's given in the problem. O doon na siyang amount sa ato ang solute. So cross-multiply, you will have here the moles times the molecular weight. But we need to isolate the molecular weight. So divide both sides with the moles. So 4 grams divided by the number of moles, you will get the 117.10. So ang atong unit, take note, this is in grams. Ang sa baba kay moles, that is why we have here the grams per moles. Ayan. Questions about problem number 2. You only have 3 persons here who got the correct answer, 117.10. So sundon lang ninyo ang atoang process ha. I will have more problems tomorrow, practice problems. I'll also give additional problems for the exam na additional points tomorrow. So let me just finish this first para diretso-diretso ta sa mga sample computations tomorrow. Ano sa imuhang nalibugan, George? Asa dapit. Naglibog ka. Hadlock sa more problems, sample problems tomorrow para practice before the exam. Kasi most of your exam, ano siya, computation yun siya, inyuhang exam. Kaya remember, kung balikan ninyo atong coverage sa atong mga nahuman o discuss, puro yun siya computation. Okay, so do not forget the formula. Ha? You can list down all the formula nga na ata para for your reference. Ha? You can do that. Kaya medyo daghan-daghan na ato ang formula. Yeah, another problem tomorrow. Wait lang. Let me delete first. That is for the freezing point. Again, our rule for the freezing point, pag magdagdag ka og solute, the freezing point will be lowered or depressed. Yeah, plus points gihapon tomorrow sa mga maka-answer sa akong mga ihatag na problem. Okay? So the last one, class, the last one, na colligative property is called the osmotic pressure. Actually, it's osmotic pressure elevation, just like the boiling point. So partner has si vapor pressure ug si freezing point, mag-lower sila pag mag-add ka og solute. But si boiling point ug si osmotic pressure, mag-increase pag mag-add ka og solute. So when you say osmotic pressure, it's actually the pressure that we need to stop the flow of the solvent or to stop the osmosis. I'm not sure if you heard the term osmosis, but when you say osmosis, class, it's the movement. It refers to the movement of your solvent from lower solute concentration nga area to higher concentration solute na area. So mag-move imuhang solvent, and then most of the time si solvent nato kay water. So do not confuse osmosis kay diffusion. Kasi we know that diffusion is the movement of solute. Take note na si solute ang nag-move pag diffusion. So movement of solute from higher to lower concentration na area. So for example, you have a container like this, daghan ka og solute dinhi, nya diri sa pikas gamay lang imuhang solute. Pag moingon ka og diffusion, ang kanang solute na mo transfer dinhi sa pikas. Okay? Through a semi-permeable membrane. Mo transfer na siya dinha sa pikas. So the movement is from higher solute concentration to the lower. That is again diffusion. But when you say osmosis, it is referring to the movement of your solvent. And then again, most of the time, our solvent is water. So movement of solvent or your water from higher to lower solute concentration region. So the movement is still from higher solute, baliktad. Sorry, it's baliktad. Wait lang. Baliktad. Lower to higher, this one. From lower to higher. Baliktaro na to, ha? So the movement is from lower to higher solute concentration. But this time, ang nag-move kay si solvent. So, para ma-stop ang osmosis, kailangan na tuog osmotic pressure. And for colligative properties, pag mag-add ka og solute, mutaas ang osmotic pressure. Meaning, mas taas ang pressure nga kailangan na to para ma-stop ang flow or ang movement sa water or sa atuang solvent. So this is how it looks like, the osmosis. So the net movement of solvent molecules from a region of lower solute concentration to one with a higher concentration. So example, you have a semi-permeable membrane here. You have kanang mga bilog-bilog mo na imuhang mga solute. So as you can see, you have lower solute concentration on the left, and then you have higher concentration on the right. So pag osmosis class ang nag-move si solvent. So mo ni siya ang iyahang result. Si solvent din sa left mag-move to a region with higher concentration. So the purpose of osmosis is actually dilution. Para ma-dilute ang area na daghan kaayo og solute. So mo ni siya class, let's apply this one, si osmosis. I believe you know na kapag hypertensive, when you say hypertensive, high blood in layman's term, pag hypertensive ang person, unsa ang bawal? Di ba bawal sila magkaon o kanang mga salty foods? Kay mutaas daw ang ilahang blood pressure. Actually, the one that will explain that is osmosis. Nganong mutaas ilahang blood pressure kung magsige sila kaon og salty na food. Kanang daghan og asin. Bawal gina siya sa hypertensive. So, ingani ang mahitabo. This is the blood vessel of the person. Ayan. So, pag ang person class is magsige siya kaon og kanang salty food. So si sodium, adto na siya sa blood. And ang mahitabuan na daghan na siya kaayog sodium sa blood. Mahimo na siya og concentrated with sodium. So pag daghan na kaayo og sodium sa blood, kay nagsige siya kaon og salty foods, actually kailangan na siya i-dilute. So magkaroon og osmosis, which means ang water from the other part of your body will undergo osmosis, mag-move na siya, ma-transfer na siya dito sa blood vessel nga daghan og sodium para ma-dilute. So magkaroon kag daghan nga water dinhi. So pag daghan ang water class nga nag-move sa imuhang blood vessel, ang mahitabuan na mudaghan pod ang volume sa blood. And ang result, mutaas ang blood pressure. Nganong mutaas man ang blood pressure? Kasi when you say blood pressure, it's the pressure required or needed for our blood to flow. For blood to flow. Now, kay nidaghan man ang imuhang blood, so mas daghan ang force na kailangan para itulod imong blood para mag-flow siya. Muna ang ginami niya. So kay nidaghan imong blood, mas taas ang force, it means mutaas ang blood pressure. So muna siya nga, dili jud advisable for a person na hypertensive na magkaon og salty foods. I hope that's clear. That's the application of osmosis here para masabtan ninyo siya. So if you have someone na like a family member na hypertensive, please advise them not to eat a lot of salty foods para dili mo taas og samot ang ilahang blood pressure. Kaya mag-osmosis na siya. Actually, no need to explain to them what is osmosis. Just have to remind them na dili dapat sila magsigig kaon ng salt. Pero as a healthcare professional, we have to know the rationale behind. So take note, class, na solutions injected into the body must have the same osmotic pressure as our blood. Meaning the solutions na kailangan ato ang i-inject sa body should be isotonic. So when you say iso, that's the same or equal, so ang tonicity niya sa blood, which means the same amount of salt. Man na ang ginamin sa isotonic. So as medical professionals, 'di ba, naga-injecta og mga substances sa like intravenous na injection, example drugs. Ina-inject nato na siya directly to the vein, directly to the blood. Ang uban, kung ma-hospital ta, we have the dextrose, 'di ba? IV gihapon na siya. Diretso gihapon siya sa blood. Now, kapag kadili the same ug osmotic pressure ato ang gi-inject sa person, that will be very painful. So kung napansin ninyo, pag mag-inject og substance sa ato ang body, dili siya painful. Ang painful lang din pag-inject sa needle. Pero pag sulod sa substance, wala siya pain. Kasi we make sure na the substances na gina-inject nato have the same osmotic pressure with our blood. So isotonic siya with our blood. The same ang amount sa salt. Okay? So dili tapataka og inject nga for example mag-inject ta og tubig sa ato ang vein. Dili na siya pwede kasi water dili equal ang osmotic pressure ni water ug ni blood, meaning wala siya the same amount of salt. Pag kag water lang gid na siya, so wala siya salt, dili siya the same na osmotic pressure. So natay mga ginatawag class og hypotonic solution. Mao na siya ang mga less concentrated solution nato, just like water. Water actually is considered hypotonic solution kay mas gamay ang iyahang solute. Usahay gani wala siya solute nga na-dissolve. So if i-inject nato na siya sa ato ang blood serum, ang mahitabo mag-expand ang ato ang red blood cells kay mag-osmosis man. Anong mag-osmosis? Pag-inject nimo, if this is your red blood cells, and then nag-inject ka og water, si water class mag-undergo osmosis, musulod na siya sa red blood cells. Kasi mas daghan og solute sa sulod ni red blood cells. Diba remember the goal for osmosis is mag-move si solvent sa region from lower to higher solute concentration. So pag sulod niya class sa red blood cells, mudako na siya, mo expand na si red blood cells hangtod na mubuto siya, mag-rupture or mag-hemolyze. So muna siya ang reason na bawal mag-inject og mga hypotonic solutions sa ato ang patient. That is also painful for them. Now, another thing, di po ta pwede basta-basta mo inject og hypertonic solutions. Pag may kag hypertonic solutions, these are more concentrated solutions nato, meaning mas daghan siya og solute na content. So pag i-inject man gud nato ni directly to the blood, baliktad ang movement. So for example, this is again your red blood cells here. Ni-inject ka og kanang hypertonic solution. Example, daghan kaayo nga sodium imuhang gi-inject. So the movement is baliktad. The water inside the cell will go out. Mag-undergo siya osmosis, pero baliktad. The water will go out kasi ang solute nga region naa sa gawas. That will make the red blood cells shriver, mag-shrink na siya, and mamatay gihapon. So the ending for hypotonic and hypertonic solution kay mamatay gihapon ang cell. So mo ni siya ang illustration. Pag isotonic ang ato ang solution, normal lang siya ingani. Kasi parehas lang ang solute sa sulod ug sa gawas sa cell. Pero pag hypotonic, mas daghan og solute sa sulod, so mosulod si water, the red blood cells will expand, mag-swell na siya hangtod mag-rupture, mag-hemolyze. Pero pag hypertonic solution or concentrated solution atong ihatag, the movement is on the opposite side. The water inside the cell will go out, mag-shrink ang atoang red blood cells, and then we call it crenation or crenated na red blood cells, and then mamatay gihapon siya. So that's it. So it's already